Hi everyone, this is the third video for section 5.1 on divisibility rules. So last time we talked about these divisibility properties, right? When a number is divisible by 2 through 12 is what we talked about in the last video. So we should be able to justify all of these rules. So we're going to go through, I know I've already talked about some of the justifications, but we're going to go through some of them in a little bit more detail, or to do ones that I had not talked about yet. So the first one we're going to talk about is 4. A number is divisible by 4, right? We talked about it being divisible by 2 twice, right? And that's just because 4 is 2 times 2, right? So if you can divide by 2 twice, then you can divide by 4. That's exactly the same thing. But we're going to talk about this last 2 digits form a number divisible by 4. So in the last video, I just kind of briefly said this is because 4 divides 100. So we're going to make that a little bit more formal now. Okay, so we want to justify the divisibility test for 4 using a 4-digit number. Okay, so it says using a 4-digit number, but really you can do this for any digit number. But just to make things simple, we're going to specifically look at a 4-digit number. Okay. So I'll keep writing in blue. So we're just going to let A, B, C, D be a 4-digit number. So we want to consider A, B, C, D, this 4-digit number. And, well, what does this number really look like? So we're working in base 10 here. So let's write it in expanded form. So then we can consider this in expanded form, A, B, C, D. I really tend to write it like this. So we have A, B, C, D in the ones place. Well, I'll just try 1. In the ones place, the tens place, the hundreds place, and the thousands place. So when we write this in expanded form, this is just A times 1,000. So this is 1,000 A plus 100 B plus 10C plus D. Okay, so, right, you could have written this A times 10 cubed plus B times 10 squared plus C times 10 to the first plus D times 10 to the 0, but we've written that so many times that I just kind of skipped to this step. So what can we notice? So we notice, right, like I told you in the last video, 4 divides 100 because 4 times 25, let me write this a little better. 4 divides 100 because 4 times 25 is 100, and 4 divides 1,000 because 4 times 250 is 1,000. Okay, so we notice that 4 divides 100 and 1,000. So we want to say that we want to use a property here. So we want to say then 4 divides 1,000A and 4 divides 100B. If you don't know why this is true, stop and think about it. Think about why this is true. And the reason is because this is by the product property of divisibility. So we talked about the properties in the very first video. So this is by the product property of divisibility. It says that if 4, right, we talked about this and said if 4 is a factor of 1,000, then it's a factor of any multiple of 1,000. Similarly, if 4 is a factor of 100, it's a factor of any multiple of 100. So this is by the product property. Okay, so now we can see that by the sum property, 4 divides 1,000A plus 100b, right? So this is by the sum property that we justified back in the first video. Okay, so now we can say that if 4 should divide the whole thing, if 4 divides the whole 4-digit number A, B, C, D, then 4 has to divide 10C plus D, right? Because we already know that 4 divides this first part. And so if we know that 4 already divides this first part, then if it divides the whole thing, then also this last part has to be divisible by 4. So we know that if 4 divides A, B, C, D, then 4 divides 10C plus D, which is essentially saying that 4 divides the number C, D. Meaning that 4 divides this last 2-digit number, or the last 2 digits, which is exactly the test that we had. We said that a number was divisible by 4 if the last two digits form a number divisible by 4. That's exactly what we found here. So you can do 8 in the exact same way. So if you want to kind of challenge yourself and see if you understood what was going on here, you could do this exact same thing, justifying the divisibility test for 8 with a 4-digit number, and it works in a very similar way. So this is kind of an expanded, more formal version of justifying the divisibility test for 4. And we can do the same thing to justify the divisibility test for 3. So again, we're just using a 3-digit number just for ease, but you can do this for a number of any length. So we're going to let ABC be a 3-digit number. So again, we're going to write it in an expanded form. So this is 3 different values in the hundreds place, the tens place, and the ones place. So this is 100A plus 10B plus C. Okay, so what do we know that's really close to 100 that's divisible by 3, right? And in the test above, we saw that 4 just divided some of these multiples of 10, but 3 isn't going to divide any of these multiples of 10. And we're trying to get a sum here. So we know that the number 99 is really close to 100 and also divides 3. So we can say that this is 99 plus 1 times A plus 9 plus 1 times B plus C. And this is just using a substitution, where we just substitute 100 is 99 plus 1 and 10 is 9 plus 1. And so now we can use our distribution. So this is 99A plus 9B plus B plus C. And this is using distribution. And then we regroup. We use the associative property. So we look at 99A plus 9B, and then we are left with A plus B plus C. And this is the associative property. Okay, so we've rewritten ABC as this sum of different things. So just like before, so by the product property, since 3 divides 9, that tells us that 3 divides 9B, and we have that 3 divides 99 tells us that 3 divides 99. Oof, that looks kind of bad. So that tells us that 3 divides 99A, right? So that's the product property. And then we again use the sum property. So by the sum property, 3 divides 99A plus 9B. So for 3 to divide ABC, 3 must divide A plus B plus C for the exact same reasons as before. We already know that 3 divides this part. So for it to divide the whole number, it also has to divide this part. And that's exactly the test that we were looking for, right? Is that a number is divisible by 3 if 3 divides the sum of the digits. And again, you can do this exact same thing for the test for 9. That's almost the exact same as this. Okay, so these were just some examples of justifying these divisibility tests. So that's all for this video.